Building a real-life NLP application means you have to perform various steps from data acquisition, data cleaning, all the way to model building, deployment, and monitoring. All these steps combined is called the NLP pipeline. Today we will take a real-life use case and understand the NLP pipeline. The example I'm going to use is Camtasia support ticket system. Camtasia is a video recording software, and like many other softwares, they have a support system where when people have issues with their software, they report here and issue a ticket. The challenge with tickets is how do they know which tickets are higher priority and have to be immediately dealt with compared with tickets which are lower priority and can be dealt with later on. So you can either tag these priorities manually or create an NLP system which can analyze the text and tag the priority based on its analysis. So let's say you create a machine learning model which can look at the title and the description of the ticket, and it can tell you if it's high, medium or low priority. If it is high priority, you can have a tool like Sentry which can monitor the logs and send alarms, and it can send a call to the customer support center where someone can immediately address the query. If the ticket is low priority, you can create a Jira ticket so that it doesn't require immediate attention but can be looked on at some point of time. Camtasia will have some software team which has created this ticket management system, and they will be saving these tickets on some database like MongoDB. And so you have your tickets in JSON format, which is a popular format where you can have different fields of the ticket like title, description, creator, severity, etc. So let's say Camtasia has been running for 5 to 7 years and we already have 10,000 tickets in our system, and that this is our historically reliable data. So the severity high to low means that we have the training data set which tells that if the description is like this, then the priority is high or low. But for simplicity's sake, assume we have this information. Now in any company there is an AI or data science team. Let's say this team wants to build this particular model which can auto label severity. So they will go to the ticket management software team and get access to the MongoDB, ask for access to the MongoDB, and will get access to the MongoDB via some shared object storage space like Amazon S3, which is basically a cloud or bucket sort of place where you can dump your data and use it. This step is called data acquisition. Many times you don't have a training data set available. In that case, you have to use a public data set or do something called product intervention, which is when you create some monitor in the product which continuously shares performance data. Some ways of data collection are by using a public data set. You can use web scraping, scrape the internet to collect the data you need. Product intervention, data augmentation, which can be used to create 100 samples out of 10. Let's say NLP team now got the data from the Amazon S3 bucket. Now we are looking for one record for one such ticket where what we can do is we can just discard some irrelevant information. So creator timestamp can be discarded. Title and description is something you can merge and you can create a single body of text. This is called discarding irrelevant information and creating a simplified version of your data. Then you can do spelling correction, removal of extra line breaks. All of these things together are called data cleaning. Now in order to build an NLP model, you have to split this into separate sentences. And one way to do this is by using sentence segmentation. It just looks at the dots and the question marks and splits the sentences. Now using the dot rule, you would end up sometimes getting 3 sentences out of 1. Once you have created separate sentences, you can separate the words before creating the NLP model. So this is the word tokenization. Now let's say that from a big text block we created sentences, and from sentences we created individual words. Now let's do further processing by mapping the word loves to love and eating to eat, which is simply mapping the word to its base or version. We can use simple rules like removing ing from words. So this process is called stemming. But it doesn't solve all of our problems like ate, which will not be mapped to eat because stemming doesn't know grammar. So then you can use a process called lemmatization, which means mapping a word to its base word using grammar. So ate is the past tense of eat, so you are using lemmatization to achieve the base words. So this summarizes the whole process. You got the sentences separated, the words separated, and then converted the word to their base versions. Now this is called pre-processing. Now the next goal, our main goal, is to create a classifier which can label the priority based on text. Machine learning models do not understand text, they always ask for numbers. What you can do is you can create some formula which can convert these words into numbers. But the numbers need to be a meaningful representation of these words, so that similar words have similar number representation, and the process of converting words into numbers is called feature engineering. And feature engineering means you're extracting features from these words. So if it compares to cricket players and derives some features and then assigns zeros and ones, this creates a vector. There are various popular techniques for this word to number conversion: TF-IDF vectorizer, one-hot encoding, word embedding. The next step would be to create a machine learning model, and now we will use naive based classifier or SVM or any other classifier for doing classification on our on our 10,000 tickets with labels. And in the future, if a new ticket comes up, you can feed it into this model and it will tell you if it is high, medium or low priority. Now to figure out which model is the best model, you can use grid search CV. Now we will evaluate our model using something called confusion matrix, where you will have your x-axis, which will be your predicted, and your y-axis, which will be your truth. And using this, you will get the number of records you predicted. Your predicted high priority versus many the amount that were actually high priority. And using this, we can figure out how good our model is. So we build a model, we evaluate using grid search, CV and confusion matrix, and if things don't look good, then we go through the whole process again, iteration after iteration, until you find a model which performs the best for you. Once your model is built, you can save it into a file and upload it into cloud. You can write a Flash service which can work on web pages or HTTPS. You can also deploy it to an end-to-end machine learning platform like Databricks, Amazon SageMaker, Azure Machine Learning. And once the service is deployed, you don't need to manually monitor and update it periodically. You have to set up some kind of autonomous monitoring for the model. So we need a good monitoring and update system.